Then coming to the series RL network, electrical RL network, for step input, what is the response? So to simulate and study the transient response of series RL circuit for circuit where by using MATLAB, not PSpice. So where R is equal to 100 ohms and L is equal to 10 millihenry, the following conditions. For source voltage is called 10 volts DC with all initial conditions set to 0. Source voltage is 10 volts DC with initial conditions IL of 0 minus is equal to 20 milliamps. Okay. By taking the initial conditions 0 and by taking the initial conditions IL of 0 minus is equal to 20 milliamps, we can understand the response of electrical circuit per step input. So for case 1, step input 10 volts DC is called like step 10 into U of t. V of t is equal to 10 into U of t. And then apply Laplace transform V of s is equal to 10 by s. And then we know relation I of s is equal to 1 by L into 10 by s plus R by L. So I of s for series RL circuit, what is the current expression I of s? So I of s is equal to, this is called series RL circuit. I of s is equal to 1 by L into V of s by s plus R by L. So substitute this and in this equation, and we will get like this. Where is that circuit for series RL circuit? Series RL circuit. Here I of s is equal to 1 by L into 10 by s plus R by L. Then 1 by L into s plus 10 by s into s plus R by L. And then by substituting the values of and simplifying 10 by s R plus partial fractions separate like this 1 by s, 1 by s plus R by L. Taking inverse Laplace transform on both sides. I of t is equal to 10 by R. This is called expression. By substituting the values of R and L, we will get this expression 10 by R like this, 10 by 100 into 1 minus e power minus 10 to the power of 4 to t. Okay. So minus 10 to the power of 1 minus e power minus 10 to the power of minus 10 to the power of 4 into t. This is the expression by substituting, simplifying. And then at t is equal to 0, what is the current I of t is equal to 0. At t is equal to 0, current is also 0 for series RL circuit. And t is equal to infinity, substitute here, t is equal to infinity, it will become 0, 10 by 100, that is called 100 milliamps. Okay. And then time constant is called L by R, 100 microseconds, this is the time, so this is the current. At t is equal to 0, the current is 0. The t is equal to infinity, current is called 100 milliamps. Okay, this is called current response. And then we can understand by using MATLAB. Then voltage drop across the resistor is nothing but VR of t is equal to I of t into R. What is the R here? 100. 100 into 10 divided by 100. 1 minus e power minus 10 to the power of 4 divided by t. 10 to the power of 4 into t. Then 10 into 1 minus e power minus 10 to the power of 4 into t. Substitute at t is equal to 0, VR of t is equal to 0. And t is equal to infinity, VR of t is equal to 10 volts. Okay. The current is exponential is increasing, and also voltage across the resistor is also exponentially increasing. At t is equal to 0, VR of t is 0. At t is equal to infinity, VR of t is equal to 10 volts. Increasing like this. Okay. And then next voltage drop across the inductor. Voltage across the inductor is nothing but source voltage minus voltage drop across the resistor. Source voltage V of t minus voltage drop across the resistor. That is equal to 10 into e power minus 10 to the power of 4 into t. Okay. And at t is equal to 0, VL of t is equal to 10 volts. At t is equal to infinity, VL of t is equal to 0 volts. Okay. So like this we will get it. That means voltage across the inductor exponential is decreasing. Voltage across the resistor exponential is increasing. But only voltage across the inductor is decreasing exponentially like this fashion. Voltage across the current is increasing exponentially like this. Okay. And voltage across the resistor is also increasing like this up to 10 volts, up to 100 milliamps for current, 10 volts for voltage, and then voltage across the inductor is decreasing from 10 volts in this way. This can be understood by using MATLAB Simulink. Go to MATLAB here and open Simulink, press Simulink and go to create model. Okay, and open new one, and then here first series RL circuit, take series RLC branch. Series RLC branch. And copy. Paste here. What is this type of R? Then apply. Okay. And this is called inductor. L inductor. Then apply. Okay. control or rotate. Okay, like this. Series RL circuit. Place it like this. And next, what is this controlled voltage? Controlled voltage is required. Controlled voltage source is required to connect the step input in this way. RL circuit. And then here, what is the our input? Step input. Step. Take step. And the step input to what is the step for the voltage 10 volts? 10 volts. 10 volts DC. So for this gain is required to multiply gain and open right here 10 volts multiplication 10 volts and then place here connect this second terminal to the control voltage source. In this way we have to connect control voltage source. Understood? Step input. And the next what is this next what is required, that is called ground is required. Connect, take one ground and connect here. And if you want to measure the voltage across the resistor and also input voltage, take one voltage measurement, place here voltage measurement, connect this voltage measurement across the parallel to this. This is called voltage measurement. Okay, voltage across the resistor. And similarly, voltage across the resistor, this is voltage across the inductor. And right click of this voltage measurement. Okay. Press right click and format. Press flip back and like this. Okay. And connect pass to here voltage across the resistor and negative here. Take one scope and also voltage measurement here input side. Okay. Input side is also required. Place here. Understood? So like take one scope. So how many terminals are required? Voltage measurement and the current, and also take one current measurement also. Okay. Take current measurement, and place here current measurement. Connect positive here and negative to the circuit and like this. How many ports required here? 4. So like this, what is this? 4 ports required now. That's why change number of ports into 4. Then apply OK and like this, enlarge like this. And then first is called source voltage. First one is called source voltage. Connect to source voltage. Input voltage. Second one is called voltage across the resistor. Okay. Second one is called voltage across the resistor. This is called voltage across. Third one is called voltage across the inductor. Then next current. Finally current. And then the resistance is called, how much resistance according to our problem? 100 ohms, 10 millihenry. 100 ohms, 10 millihenry. 100 ohms right here, 100 ohms. 100 ohms. Apply. Okay. And then inductance is called 10 millihenry. 10 millihenry at 10. Then apply. Okay. Everything is connected. And then next, this is called step input. The step time is final starting from 0. That's why step time is equal to 0. And here start time write 0.01 and then simulate. And take one power guy. Okay. Power guy. our guy place here and then simulate. So these are the responses you will get, and press here layout style, go to style, and before going to the style, uh, press here layout, layout 4 waveforms. That's why this 4 waveforms like this, and go to lesson, go to style, press style, and your background color is called white, figure color is white, axis color also white, this is called black, and the next to active display 1, and the color change color into red, and change thickness to, then apply. Okay, so this is our input. And the second one, go to style, active display 2, change the thickness, okay, change the color like this, thickness, and then apply. Then active display 3, change the color also, and this way, then change the thickness, then apply. And then active display 4, Pascal current, and thickness, and then apply, then okay, and press this vertical. So this is our response. Okay, this is our response in a series RL circuit. Change this configuration like this for understanding purpose. First, what is the waveform? This for a series RL circuit. Here, first one is input voltage. Input voltage DC 10 volts. We will get like this. Okay. Input voltage DC 10 volts. This is our input. First one input voltage. Then next one voltage across the resistor. Voltage across the resistor exponential is increasing up to 10 volts. This is called voltage across the resistor is increases like this. Okay. And then second one, voltage across the inductor. Voltage across the inductor exponentially decreasing like this from 10 voltage onwards. So 10 voltage onwards, so this is decreasing like this voltage across. The next current expression I of t, where is the current? So here exponential is increasing now. Exponential is increasing up to 100 milliamps is nothing but 0.1 amps. So like this current is increases up to 0.1 amps. So this is about series RL circuit without initial conditions. Understood? Then with initial conditions. Coming to the case 2, what is this case 2? With initial conditions. So case 2, source voltage is equal to 10 volts, and with the DC, initial conditions are IL of 0 minus is equal to 20 milliamps. By considering the initial conditions, then what is the response of electrical circuit? So V of t is equal to 10 into U of t. We know. Okay. And then IL of 0 minus is equal to 20 milliamps. This is our DC voltage, same. And initial conditions IL of 0 minus is equal to 20 milliamps. Then V of S is equal to 10 by S. Apply Laplace transform. Then V of S is equal to, according to the formula, R into I of S plus L into S into I of S minus this current IL of 0 minus 2, because of initial conditions either exist. Then apply Laplace transform on both sides, then 10 by S plus 20 into U, 10 to the power of minus 4, like this. Simplify this expression, then I of S is equal to, we will get 0.02 divided by S plus 10 power 4 plus 10 to cube by S into S plus 10 to the power 4. Apply inverse Laplace transform, then you will get I of t is equal to 0.1 minus e power 0, and 0.08 into 10 to the power of minus 10 to the minus e power minus 10 to the power of 4 into t, like this expression, I of t expression. It current response by taking the initial conditions. And then we have to verify the initial conditions by taking the initial conditions. At t is equal to 0, the current I of t is equal to 20 milliamps. 20 milliamps means 0.02 amps. 0.2 onwards, 0.2. 20 milliamps means 0.2 amps. So t is equal to 0, it starts from 0.2. And t is equal to infinity, and I have t is equal to 100 milliamps. That is 0.1. 0.02 to 0.1. Okay, like this. 20 milliamps means 0.02. From onwards, it is increasing. Okay, for current response. Then voltage drop across the resistor R is nothing but VR of t is equal to R into I of t. R is called 100. I of t is called, substitute this, and then we will get 10 minus 8 into e power 10 to the power of 4 into t minus 10 to the power of 4 into t. Okay, then substitute t is equal to 0, and then VR of t is equal to 0. That means voltage across the resistor is start from 2 or voltage onwards, and at t is equal to infinity, the voltage across the resistor is nothing but 10 volts. And then voltage drop across the inductor L is called source voltage minus voltage drop across the resistor. VL of t is equal to V of t minus VR of t. That is equal to 8 into e power minus 10 to the power of 4 into t. At t is equal to 0, substitute here, and then VL of t is equal to 8. At t is equal to infinity, VL of t is equal to 0. At from 8 volts onward, exponential is decreasing. Okay, so this is called second case 2. Then that can be understood by using MATLAB symboling. Case 2. What is the case 2 here? Same source voltage is equal to 10 volts, and with initial conditions, IL of 0 minus 20 milliamps. Okay, and then open inductor. And what is this set initial inductor current is called 20 milliamps. 20 into e power 10 to the power of minus 3. And e power minus 3 is nothing but 10 to the power of minus 3. Then apply. Okay, 20 milliamps. This is called 20 milliamps. And then simulate. And then open. So this is our response. Okay. So we can verify this by considering the initial conditions. What is the response? So current I of t at t is equal to 0, it is 20 milliamps. Na? So that's why 0.02 onwards. And this is called current waveform. So 0.02 onwards is increasing. And finally it reached 100 milliamps is nothing but 0.1. It starts from 20 milliamps. It means 0.02 and ends at 0.1 amps. This is called inductor current. Okay. And the next voltage across the resistor. Current is over. Then voltage across the resistor. It starts from 2 volts and ends at 10. Start from t is equal to 0. It starts from 2 volts. Here, voltage across the resistor start from 2 here onwards. Here. So start from 2. This is called voltage across the resistor. Second waveform is called voltage across the resistor. Start from 2 and increases to 10 volts. Okay, this is our voltage across the resistor. And the next voltage across the inductor and starts from 8 and decreases to 0. At t is equal to 0, voltage across the inductor is nothing but 8 volts. And at t is equal to infinity, voltage decreases. And here this is called like this, 8 to 0, exponentially decreasing. So 8 onwards, from 8, this is called voltage across the inductor, is decreasing exponentially in this way by considering the initial conditions. Understood? So this is our response of series RL circuit by considering initial conditions and with and without initial conditions. This is about electrical response of electrical network per step input signal.